Dovidajcie.
Hello, today we are making presentation on the paper Design of Sobel Operator Based Image Edge Detection Algorithm on FPGA. Due to the paper's complexity and the language used by the author, we decided to go by the low budget Sasatilo edition. So here we go. Introduction. So for the introductory part, the author basically talks about how the FPGA chips are good for the phase detection because of their qualities. For example, one of the main reasons why the author thinks that the FPGA chips are better than the sequential chips is that they take few clock cycles to process the information as they have as they can in parallel process the information, while the conventional chips are not able to do that. Also, FPGA chips, as described by the author, are power efficient. They make operations more rapidly than the other chips. That's why he thinks that using FPGA chips for the face recognition technology is way better than going with the other types of chips. That was basically it for the introduction. So let's move on to the next part.
Okay, I'm gonna try to make this as understandable as possible because the way this article was written was very difficult to actually understand what this guy was trying to communicate. It basically felt like watching one of those Indian tutorials on YouTube, but with bad grammar. So from what we understood of reading this, there's like a very important thing that when it comes to image detection, it's understanding or like getting the program to understand where the edges are. So to do that, the program or like the way you do that is you basically break the image down into a two-dimensional array, one for x-axis and one for the y-axis. And then when you want to get like so basically like the edges, you to get the find where the edge is, you have to basically find where the pixels values change drastically from one another, because the and for example, like a gray pixel will always have like a derivative of 1. So that's like one of the ways that they actually go about using it. So like the edges, they all have like a very high frequency of information, and you can basically use like a high pass filter to detect the edges. You can like have there's like this method that allows you to characterize the difference in the pixel values, and then you can like break them down and actually like start working in towards the image to like actually understand them. So there's like from what I understood, there's like this thing that they came up with. They call it the gradient, and like I said, it's like a two-dimensional array, and they use the Sobel edge detection, which is basically like there's like they basically use a convolution kernel, which is like a 3x3 matrix with like a set values set into it, and they use this matrix to like run across the pixels, which will then modify those pixels and then like output them on like a different value. And then they calculate the gradient, which just shows you like how much the value of the pixels changes as you move towards like a specific point, which is the best explanation I could come up with based off of reading this title, because it really was difficult to comprehend. This was terribly written.
Unfortunately. Moving on the next part, Sobel edge detection system architecture. As you can see on this, as you can see on this slide, we have two figures here. Figure 2, which shows Sobel edge detection architecture. We have, as you can see, when pixel data in goes in, it goes through several things, through FIFOs to shift registers, and then from shift registers it goes to Sobel edge detection, which basically has convolution, addition, and threshold comparison. And for the memory architecture, what was the, let's say, important part is that there are two FIFO memories, and through FIFO memories, the data goes into the shift registers, and from the shift registers, then the data is transferred to the other part of the system, basically. That's basically what I can say about this part, because most of the information that was written there was like Nico said, it was too hard to comprehend at some point, but basically you get the idea of what's going on here. So next part.
Okay. Okay, and the last paragraph that was written here was about the test benches. So like a test bench is basically like a special type of code that you can use to test that you can use to test like real inputs of how the hardware would react to like real inputs. So from what I understand, like we studied this in class, we know that VHDL and other like hardware descriptive languages can read from text files. So you can have like something like MATLAB that can, well, this is what this article says. There's like, you can have like MATLAB, you can obtain raw image data from that, and then you can convert that to, and then you can convert that raw image data into like a text file, and then you can have the test bench use that and then give you the output. This last part was like cryptic at best. I have no idea what was written in here, I'm going to be honest.
In the article, there was also experimental results given. So as you can see, there are some experimental values here, like in the tables here. And basically that's it. Just to answer the question, if there were experimental results in the paper, here they are, as you can see, like 3 tables. And for the conclusion, let's just say that it was, let's say the author basically repeated what he said in the introduction. He again elaborated on the good side of the FPGA chips, how convenient they are for the face recognition systems, how affordable they are, how it's easy for how it is easily accessible, how it's easily transferred to market, and basically that's it. Thank you very much.
And that concludes the presentation. Thank you very much.
Thank you.